I should probably also share my screen, huh? That's what I'm supposed to do. Okay. Welcome all. This is homework 6, part 1. What's so funny about homework 6? It's just homework 6. I'm glad you can join me. Let's see. What's the first thing we should check? Let's start by knitting this document. Also, if you are here in person, do you have access to the data on your machine already? Because I ran into the problem of not being able to download it because it assumes things are viruses. I'm sure you all run into that if you've used like a computer machine in the lab. I came up with a workaround for it, where I just download it using R and unzip it using R. Haha. But let's start with the homework. Homework 6 is not that long. So let's hope we can still get some sunshine by the time this is over. The instructions. Pronto is Seattle's bike sharing program, which launched in fall of 2014. You may have seen the green bike docks around campus if you were before my time. It was also in the news pretty frequently and was eventually shut down. You'll be using data from the 2015 Pronto Cycle Shared Data Challenge. These data are available for download as this zip file. Once unzipped, the folder contains all the files, is around 900 megabytes. The folder Open Data Year 1 contains a readme.txt where you can see all of the reference materials for documentation. You're going to want to place the Open Data Year 1 folder in the same directory as your template. An example would be like this. My homework is in the same place as my directory, and the data look like this. Let's check out this notepad. Let's not check it out on base notepad, shall we? Great. But it tells you all the kinds of information you might want to know about, like what each of the data is, what columns you have within each of the data sets, and a little bit of information like first rows contain column names. Trips that did not include a start or end date were removed from the original table, that kind of information. Right, because the Pronto bike sharing program was dock based. So you would start pulling it off a dock and then you would ride it to somewhere and park it in a different dock. And this is a far cry from like Lime bikes, which you can just find in the water next to Golden Gardens. The questions for you to answer are as quoted blocks of text. Put your code used to address these questions and any comments you have below each block. Remember the guiding dry principle. Don't repeat yourself. Part 1. The next section asks you to load the data with a loop. As an advanced alternative, you may optionally skip this and load the data using a vectorized method like lapply. Okay, loading the data with a loop. Make sure Open Data Year 1 folder is in the same directory as this template. Use the list.files on the Open Data Year 1 folder to return a character vector giving all the files in that folder, and store it to an object called Files in Year 1. Then use subsetting on Files in Year 1 to remove the entries for readme.txt, which isn't data, and for 2015 status data.csv, which is massive and doesn't have interesting information, so we're going to exclude it. Thus, Files in Year 1 should be a character vector with 3 entries. Great. Let's start with that. So the first thing it says, make sure the data is in the right folder. we've done that. Use the, actually, one of these is named lab copy, and the other one's just, sorry, excuse me for a second while I ensure that this is, okay, we're actually supposed to be using this one and not the other one. Okay. Great. Use list.files on the open data year one folder to return a character vector, giving all the files in that folder. Okay, let's start with seeing what list.files presents us with first. So it navigated to the directory where my markdown is housed. So you can see the markdown that we're working with, the folder, the original zip, and that quick fix that I came up with for downloading the data. Do we have any ideas first on how we're going to navigate to that other folder? Not quite. We're just going to, we can specify a path here, and we can just say open data year one. And because it's in the same directory as our markdown, it's just a relative path. So we don't have to say anything more than this folder is in the folder we're already working in. I tend to like to put a / before these. You'll see that it produces the same information to put a / before it. What it does is it reminds me that this is in the same directory that I'm working in. This is a very old Unix way of relative paths. That makes a lot of sense for my brain, and it's nice. I don't know. But this is the information that we're interested in, the things in that folder.
Okay, so the markdown file should be in the same folder that is open year one, or is your markdown?
Markdown is in a folder next to actually, I'll show you. So if I remove this, my markdown is in the same folder, and then this is in, okay, yeah. All right, next, we're going to store it to an object called files in year one. And I don't need to prove to you how good I am at typing. I'm going to copy paste this. Now, files in year one is a character vector with each of the 5 files we have in that directory. Then use subsetting on files in year one to remove entries for readme.txt and 2015 status data.csv. Do we have any ideas about how we might want to subset this to remove those 2 cases?
Just subset and then do or minus those 2 file names.
The 2 file names. Sure, let's see it. So we could subset here, and then you're saying do minus, and then the character strings for them, which are here. And here. I see. This would be removing based on the names of the elements in the vector, whereas like the vector doesn't have any names yet. So not each of the elements has a title, but we were subsetting by it as if they had a title. So what we'd want to do instead is subset by the relative position in the vector. So I think it would be so our options are we either add names to this list or this vector, or we could say remove entries 2 and 5. And now our files in year 1 only has our 3 elements of interest. Trying to get it so that you can all see it on one line instead of broken up. Okay, are we cool with that solution? There are quite a few more I could imagine, but this one's getting the job done and it's pretty easy to read. Okay, the last instruction. So we're going to exclude it. Thus, files in year 1 should be a character vector with 3 entries. These are our 3 entries. Great. We want to read the remaining .csv files into data frames stored in a list called data list. Pre-allocate this using all of this information. Okay. Sounds like a good idea. There we go, data list, we made it. Good job, everyone. Next, we would like the names of the list entries to be simpler than the file names. For example, we want to read 2015 station data.csv file into data list as station data, and 2015 trip data.csv into data list trip data. So you should make a new vector called data list names, giving the names of the objects to read in these CSV files. Well, the green is doing something for my eyes. Giving the names of the objects to read in these CSV files to using files in year 1. Use string sub function and library stringer to keep the portion of the files in year 1 entries starting from the 6th character, which will drop the 2015 part, and stopping at the number of characters of each file name string -4, which will drop the .csv part. Remember to load the stringer library and use string sub in the console to get help on the function. Okay. Let's see about that. String sub is from stringer, and string sub will recycle all arguments to be the same length as the longest argument. If any arguments are length 0, the output will be 0 length character vector. The usage, let's see, we give it a string, and then we can give it a start and end. And the start and end are both integer vectors. Then give the position of the first character, and n gives the position of the last. Okay. We've used string sub in passing a couple times. I've talked about it a little bit, but I think this is our first like serious work with it. But it said that we should load the stringer package. So I'm just going to go back to the top here and add a chunk and a library stringer so that I know that's in there and that it's just going to work whenever knit the marking. Okay, let's see. I'd like the names of the entries to be simpler. Okay, so we're going to give to a new object called data list names the string sub of our files year 1 but if we start with removing, we want to get rid of like the 2015 part, which they say is the 6th character. Let's see what that does. Okay, so that's like removed our 2015 part. If you're confused about what just happened, I will compare with the files in year 1. So string sub here has taken our files in year 1, which has all of these 3-character strings, and then it has taken off the first 6 characters of each. Cool. And if we want to remove the end things, the way we do that programmatically, so like since the .csv for station data part of the string is like, I don't know, 10 characters away, and this is 9 characters away, and this is like, I guess also 10 characters away. This, we can actually coerce it to go starting from the end of the string back. And the way we say that is we do minus, and I can't remember if it's, that's just, okay. That took our last couple of letters. Is it 4? It's not -4, it's -5. Cool. Are we clear about how this is going? It's taking our character string and cutting off the ends of it. An alternative way that you might want to do this, if you, let's say I've already taken this class before and know what I'm going to talk about on Wednesday, you could say string remove all files in year 1, and then supply to that 2015 or CSV, and this will give you the same thing.
What's the double backslash?
This is telling R that this period is a period and not something else. We'll talk more about this kind of stuff on Wednesday, but I thought I'd put that on there just in case people wonder.
So that, oh wait, like if something is in 2015 was like in the middle, you just wanted it to
Go away.
put they're at different character values.
Mm-hmm. Okay, cool. Next, it says, set the names for data list using the names function in the data list names vector. Okay. Do we have any thoughts on how we might do that? Using the names function to set the names of data list. How about we check what the names of data lists already are? They don't have, they're nothing. So how could we supply to them some names? Remember, our data list is that list we made before with each of the 3 elements so that we can later read all our CSVs into it. How would we give names to these 3 things? Using this vector that we made earlier. You're on the right track. We're going to use the assignment operator instead of equal. And then we can just hand it our list of names. And so now when we look at data lists, each of the elements have taken on those names. So this is what you were talking about earlier, subsetting by like the title. That other vector was unnamed, but this list is named. So now we could subset by these. Okay, are we cool with how these names got attached to this list? Okay. You got a question?
No, there's just the data hasn't loaded on my program, so I'm just following the code, but then I can ask you.
Okay,
Right now, I'm just copying the code.
gotcha.
Yeah.
Okay. It says then, write a for loop that uses read underscore CSV from the reader package to read in all the CSV files contained in the zip file. Sequencing along the files in year 1 vector, store each of these files into its corresponding entry and data list. There's a data download demo from the second to last person who taught this class. You'll want to use the cache equals true chunk option for this chunk. Otherwise, you'll have to wait for the data to get read in every single time you knit. You'll also want to make sure you are using read underscore CSV in the reader package and not the base R read.csv, as reader's version is faster and gives you a progress bar and won't convert all your character variables to vectors automatically. That's not true anymore. I need to take that out of everywhere in this one. Anyways, since it's already saying let's use the reader package, I'm going to go all the way back up to this top chunk and make sure that reader is loaded. And then I'm going to head back down to the question and start thinking about how we're going to make this for loop. Okay. How do we start a for loop? For, all right. What's next? I, we could say I, or we could pick something else. We could say for CSV or something. So it's like a little bit more legible. For CSV in, and then what are we iterating on? Let's see. From the reader package, read in all the CSV files contained in the zip file, sequencing along, and the files in year 1 vector. Okay, so the prompt says we want to use sequence along here. Recall what sequence along does is it converts our character things into numbers so that we can subset. Here, give an example about what sequence along is doing. A sequence along files in year 1. See, it provides us with the numbers 1, 2, 3. Whereas if we just looked at files in year 1, we would have 3 character strings. Okay, so for CSV in sequence along files in year 1, what comes next after this stage? Yep, little squiggly brackets. Okay. And what is the data doing? We want to read CSV. We know that for sure. But how are we going to navigate to the correct place in the folder? The same path from before, this one. So we're going to need this. But then we need to iterate across each of our CSVs. One option that we have is we could paste together the start of our file path and each element of our vector. So now we can say files in year 1. But if we did this, what do you think would happen? Right now, what are we missing? So we need to iterate over each of the things in this vector. So we're going to subset by our index, by our CSV. Okay. Let's run it and see what happens. Okay, so far, what happens is we have 3 different read underscore CSV things that have happened. We have here the rows and columns of a CSV with a few character columns, a few double columns. This has 142,000 rows and 12 columns with some data here. So it looks like it's reading all 3 of our CSVs. But it's not saving them anywhere. So we're going to want to assign to the data list that we allocated before. And how do we want to subset our data list so that each of these CSVs goes to their own element?
My loop told me that my that file doesn't exist in my working directory.
Okay.
But my previous ran that in the first part.
I see. Then I think that perhaps you use regular paste instead of paste 0. If you get WD.
Oh wait, I didn't apply it to data list.
We were in the middle of this step,
Oh,
so
okay.
we were here before when I ran it last. Cool. Okay, so we want to assign to each of our elements of data list one of the CSVs as we iterate across our files in year one. How do we want to go about this? We can definitely apply this, but not quite yet.
Use the that double brackets to subset which part of the or to identify which part of the list is defined.
Yes. So we can use our double brackets. And here the double brackets is important because we have a list. And if we want to get to the element and retain the base version of what we're assigning to it, we want to double brackets. And now if we run this, we'll get the same sort of output here, describing what's been read. But when we look at our data list, let's say we do, I don't know, structure data list. See, we have a list of 3 things. Our station data, which has these qualities. Our trip data, which has these qualities. And our weather data, which has all of these qualities. So it's looking good. Are we cool with how that worked?
My loop ran.
Okay.
It gave me an error saying that the assigned data must be compatible with existing.
The assigned data must be compatible with existing data.
You can't run it twice.
Okay. Can you not? It won't. It'll get upset at you because there's already stuff in there.
Or I don't know, it might when I ran everything from the beginning, it just you could do it, check it out after class. I don't want to keep you wrong.
Okay.
Everything is great.
The lapply. Let's talk about how we would lapply for this. Think about this. We could say file paths and assign to that just this innards we had right here. And we actually don't need to iterate anymore, so we'll just remove that. Okay, so we see what I did here. File paths is we're going to assign it, pasting together our folder and then each of the elements of our character vector with our CSVs inside. So this is what the resulting vector will look like. It's just a path to each of these CSVs. And then we could assign to data list, lapply, our file paths, and then the function that we'll give it is still read CSV. And voila. I'll reiterate that I really liked the logic of for loops for like maybe too long in my R experience. And it took me a while, like years, to get used to figuring out problems in this way, but it saves me so much time. And I would recommend trying to start thinking about things vectorially, not a word, and thinking about things in vectors. You could even so our sorry, I was checking the structure real quick. But let's say that we didn't want to even do this step here with the assigning the list names. At this stage, we could say like set names. Data list names. And yeah, that would even save us yet another step if we set names at this part. But we're not gonna do that. We already set the names for it. But I'm sure there's somebody sitting at home just going, I wonder if I could have skipped 4 of the steps of the homework. Okay. On to fixing data types. So run structure on data list and look at how the variables came in using read_CSV. Most should be okay, but some of the dates and times may be stored as character rather than dates, or POSIX time, date time values. We also have lots of missing values for the gender category in the trip data because users who are not annual members do not report their gender. First, we're going to patch up the missing values for gender in data list trip data. If a user is a short-term pass holder, then put unknown as their gender. Do not make new objects, but rather modify the entries in data list directly, doing something like data list subset to the trip data, assign data list subset to the trip data, and then mutate. So I see here, these are out of order, this chunk and this chunk. It's okay. So we are going to fix the gender column. We're probably going to need dplyr because it's saying use a pipe and mutate. So I'm going to go all the way back up to the top. Library dplyr. Make sure that we have that. And then scroll all the way back down.
Is there a reason that reader and dplyr are both in the tidyverse?
Yes.
Package? Is there a reason you don't just do that one all the time?
I do in my own usage, but I want to keep it very explicit what each thing in each package does while we're figuring them all out. Okay, so we have our data list, and we can subset to our trip data. But there was something amiss with the gender column. So let's say count gender. And so what we'll see here is that we have 18,000 some odd people self-reporting they're female, 67,000 some odd people self-reporting they're male, 1,500 reporting other, and then our NAs are about 55,000. But what we don't know about this data is that this is actually directly related to the user type. which is to say that everyone who is a short-term pass holder didn't opt into, or I guess didn't get asked what their gender was because they were a short-term pass holder. And people who are annual members like probably filled out some sort of survey about their usage. And so we want to, for all of the short-term pass holders, replace this NA with the word unknown. So how are we thinking of that? We want to replace this NA with a new word.
So like is.na or like an if user type is short-term pass holder.
All right, yeah, I'm with that. Let's we will say,
or if gender is NA, then
I'll make a new chunk here. And we'll say data list data, and we're going to assign to this the same thing, which is to say that we're just going to overwrite information that's already in there. So I'm going to assign to data list strip data the data list strip data, and then I'm going to mutate, and our column of interest was gender. So we're going to say, we're going to override our gender column. We're going to say gender is going to be equal to, and our suggestion was if else. So we can use if else here. One thing I do want to note now that we're just kind of working through stuff, there is a different if else that is in dplyr. That's if underscore else. And one of the basic differences is that it is less careless, maybe, about your underlying data types, and it will be faster in the long run if you use if else and know that your underlying data types are all going to be the same. But we don't have to necessarily use that in this case. So we can just use base if else, and then we'll say if else user type equals short pass holder, return unknown, otherwise gender. And so here we're really relying on this like nuance of the way that the data came to us, which is that all the short-term pass holders were the ones who had the NA. And we can run that. And now we can say, we can actually just go back up here and run this. And now our gender for all of our short-term pass holders is unknown. All right, are we cool with this? Great. What was the other thing?
actually, can you also give the example of just because I feel like that's more applicable to work that I've done of just replacing NAs, like if gender is NA, then gender is.
Sure. So we could say if else is that NA gender. Now use dplyer's mutate. You may want to use the helper function across functions from the lubridate package and the factor function to fix any date times, as well as to convert the user type and gender variables to factor variables from the trip data. Don't make new objects, but rather modify the entries in data list directly. Okay. Well, it's asking us to use the Lubrate package. So I'm going to scroll on back up. Make sure that we have Lubrate. Excuse me. Okay. So we're going to go back and revisit structure of data list. Yep.
That's fine.
Yes. So it's telling you that some of the
I didn't know about.
yeah, no worries. Some of the functions that Lubrate has the name of is going to be preferred over other functions that are already available to your R instance. And so that if you want to use, let's say, the base R date function, you're going to have to specify it like this.
Right.
But you basically wouldn't want to do that because you're already using Lubrate. But I've been surprised. No worries. Okay, so we are going to check the structure of data list so that we can see which of our things are date times. So let's start at the top. The station data has ID and name and terminal and latitude and longitude and dock count and online. Yeah, this is too much work for me to read through it like this. I'm going to go to our wonderful what is the name of these? Codebook. And our trip data has our start time and stop time, as well as the weather data, I believe, also has a date. But, okay. So we want to change our trip data without creating a new object to ensure that our dates are date objects. So we'll start with data list, data, and assign it trip data again so that we can just overwrite what's already there. And then we're going to use mutate, asking us to change a column. You may want to use the helper function across. Now, why would we want to use across here? So across lets us select multiple columns and then do the same thing to all of them. We're going to say across, and we can give it a vector. So our start time column and a stop time column that are both available in our trip data. We'll say comma, and we'll also to convert things to a date. There is a bunch of acronyms that are reliant on the way that the data comes in. So here we have our start time, for instance, and our stop time. And our data comes to us as month, day, year, hour, seconds, minutes, goodness. And so since we know that it comes month, day, year, space, hours, minutes, what we'll say is month, day, year, hours, minutes. And that's the function that will convert these things to days. So if we can run that, now when we say structure data list and our start time and stop time are POSIX. That's the type of column. And the format is going to be the format that everything should be in, which is slowest things first, year, then month, then day, then hours, then minutes, then seconds. And it assumes that all of the seconds are just at 0, 0. We also wanted to make the fix any date times. So we did have some date times from the weather data. So we'll say data list weather data and assign that data list weather data. We'll be doing much the same thing, but we need to check on how that column looks in order to take advantage of these lubridate sort of acronyms. So here, our weather data, we have the date column, which comes to us as just month, day, year. So we can just say mutate date is equal to mdy date. Note we didn't have to use a cross here because we only have one column that we're changing, and it didn't have hours and minutes. So in order to convert it, we can just use mdy. And now if we look at data list, there's data. Oops. Our date is type date. Okay, are we cool with those? And the last thing, fixing the date times as well. And the factor function to convert the user type and gender variables to factor variables from the trip data. Okay, let's see here. So we're already changing the trip data in this chunk, this little block of code here. So we could just add a chain to it and say mutate user type equals factor user type. And then comma, we'll hit enter so it's a little bit more legible. Gender equals factor gender. Format found. I see. Since it's already been converted to a date, we don't have to do that. What we should do, actually, I tried to save time. What a fool I was. We could just do this instead. And now when we look at a glimpse of our data, he's got messed up somewhere. I think trying to overwrite it messed him up. I'm going to start back at the top and see if I can't fix it. So it's not. Okay. Did data list names not go to them already? Okay, we did that. Okay, so that's why I needed the set names idea. Okay. I see what happened. Okay, so now our start time and date time are fixed. Our start time and stop time are fixed. Because I tried to coerce a thing that was already a datetime object into a datetime object yet again, it gave me back some NAs because they were ill-shaped. And then when I went to fix it back, the vector that I needed to make the names for the list, I had not assigned to the elements of the list. And then when I needed to use those names to subset the list, it didn't know what I was talking about. And now we're back here and everything's hunky-dory. Great, so our date is date time, and our user type and gender are factors. Great, that's it for part one. I'm gonna go ahead and turn off the recording and then we can troubleshoot any problems that you had.